The next section, for the rest of the day, we'll do a section on implementation, which is what tools can we use to, now that we've discussed metrics, we've discussed methodologies, we've come up with sets of metrics that we'd like to observe. This is where reality, where rubber meets the road, and it's now reality. What tools exist for us to actually deploy this in our environments? There's one very simple way to answer this, which would be buy Theo's product, and then we can go to the next section. But it's also useful to look at what other products exist, how people worked on building it. This is something that Kasky's done a lot of work in, and so if you wouldn't mind, I'd like you to lead this section. And then after this section, a very brief, like a 5-minute statistics crash course, and then however many minutes left for some visualizations.
Yeah. Let's see if this works. I'm going to be using my notes from my talk tomorrow as kind of crib sheets, just because a lot of what I want to talk about is in there. We already talked about a lot of these things. Here we are. This is the general model that I'll be presenting tomorrow in nauseating detail, but essentially, when you're building a monitoring system, it's my contention that you have to solve all 7 of these boxes, okay? Now, you can solve them in lots of different ways and to greater or lesser degrees of quality and utility, but no matter what you do, if you're going to monitor something, you need all 7 of these boxes. You can't leave any out and still have a monitoring system, okay? Essentially, we have sensing and measurement is what we're talking about. We talk about much of what we talked about today with what metrics do you want your processes to be able to produce that you can then read out and see, you know, how many errors have you been producing as a counter? What is the distribution of latencies over the last 30 seconds of reads and so on. Collection is the problem of bringing that data together, because very often the data is useless in isolation. Okay, you want to take not just all of the I/O counters off of this server, but you also want to take them across all of your servers and look at the total together. Analysis computation is when you begin doing things where you compute derivatives, derivatives, comparisons, ratios, where you're mixing and matching metrics together. Looking at how things like your incoming HTTP request rate relates to your disk instruction queue length. Okay, alerting and escalation are where you begin to highlight things and bring and basically be noisy about something that may or may not be interesting. Basically, when you do find anomalies or things of interest in the analysis phase, you do something with it. Now, from an operations perspective, the alerting is a very immediate sort of thing. In the capacity planning, it's much less immediate. You usually need to know, when is my projected disk utilization going to, are we 30 days from 100% or whatever high watermark that we have specified for buying new equipment. You need to know that. It's not quite as urgent as, you know, you're at 100% right now, somebody please do something about it. Visualization, this is a very broad category, and we're gonna have a bit at the end where we talk about this, but I lump in here all attempts at taking what would otherwise be just massive, massive, massive tables of time series and trying to present them in a way that is useful and interesting and actually provides actionable knowledge. The heat map is an excellent example of a really useful visualization. If you looked at that data in just about any other way, you could not, without spending orders of magnitude more time examining the data, come to the quick and easy conclusions that you can by just looking at a heat map or a histogram. Okay, that all comes from visualization. That's your Tufte and your Few books. I mean, anyone who's designing dashboards really needs to read those books, because how you present the data can be the difference between an immediate diagnosis and basically going down rabbit holes looking for information that may or may not be there. Storage is important because that often impacts your throughput and how you can access the data. There tend to be, I think, there are right now there's 2 major family trees of storage technologies. There's the RRD tool family, and then there's I want to call it the MRTG family, but they've mostly switched over to RRD tool anyway. And then there's the others, like the OpenTSDB, and then homegrown solutions that are just making whatever they want as far as their storage. How you store your data affects how you can visualize your data, because it impacts your ability to produce time series. Anyone who's connected a Ganglia configuration writing to OpenTSDB with a Graphite front end will rapidly discover there are many ways to make Graphite cry and the user cry when it tries to produce these web. Who's tried to do that? Oh, no one? Huh?
Not Graphite and OpenTSDB.
Okay.
Well,
Who's
both of them.
Who's ever made Graphite cry? Yeah, yeah. When Graphite works, it's great though, right? Yeah, and it's not the only one. So there are libraries that help us do this, but my problem is with web apps, which are well studied and well established, we have a general model of how these things are implemented. You've got load balancers and distributors up the front, you have web servers, you have application servers, you have a storage layer of some kind, and we have what I want to say interchangeable parts, but they're not truly interchangeable, but like I can decide whether I want to use, what is it, UX, the web server again. NGINX. I always blank. Yeah, I'm not going to forget Apache. That's been driven into me. So I used to use Apache, and then NGINX came along, and I was out of business. And so, yeah. So you can decide whether you want to use NGINX or Apache without really changing how you do your job of deploying your app. You can decide whether you're using Tomcat or one of the other Java App Engine providers. I'm sorry, the Java servlet container providers. You can actually decide, do you want to use PHP or do you want to use Java without really impacting your choice for your accelerators and of your storage layer. You can choose PHP, MySQL, Miranda, and going on, MongoDB, and go on and on, without really changing the entire architecture of your web app. That doesn't exist in monitoring. If you decided, I'm going to switch from using RRD tool to using OpenTSDB, you basically have to rewrite your entire monitoring system pretty much from scratch. I would like to see us moving toward a world where we have more interchangeable components. Now there's some bright light on the horizon that this kind of thing is happening. I'll go through all this stuff in my talk. But when we look at implementations, okay, MRTG and Nagios. These are my two favorite things to start with because pretty much every monitoring system out there can be traced back to either MRTG or Nagios. They are descendants of one of the two. And one day I'd like to make a family tree of this, but I think it'd be really boring and depressing. So MRTG is not a complete monitoring solution because it lacks alerting and in kind of analysis. I mean, it does some basic smoothing and aggregation, and it only tracks, it's got a very weak data model, 2 values, that it's dominated by the notion of monitoring network switches. I know this is 15 plus years old, right? But if you then fast forward to, let me get to, Ganglia, which is still 10 years old, you'll notice the graphs look a lot alike, right? Ganglia takes one of the weaknesses in MRTG, oops, where did I get them? Which is the collection layer. MRTG collects via SZMP only, right? And it works as a single daemon that must reach out directly to all of the things it wants to read data into and produces graphs. Very quickly, if you're working in a large-scale system and you like being able, if you're monitoring basically, I want to be able to look at graphs and see how busy my system is, you're going to rapidly realize if I have 1,000 machines in my compute cluster, I can't have one job which, when it runs every minute, opens up 1,000 connections, reads down all the metrics, and then regenerates, because every time you run MRTG, it actually regenerates every one of these PNGs, okay? And it's 4 of them per metric, and it generates a whole bunch of web pages. It's kind of this one-time run thing. Very old school web stuff. And so Ganglia, who here uses Ganglia? Yeah, Ganglia, if you look at its UI, it's a direct evolution of solving the collection problem that was in MRTG. Somebody said, I want MRTG, but I've got a whole bunch of hosts, and I don't want to go and configure them all and manage it all. And so Ganglia focused very much on solving the collection problem. Yeah?
Well, I think that comes down to a typical use case for Ganglia, because it's actually broken out into modules. Mm-hmm. The default Ganglia web interface here is very much derived from MRTG with RRD underneath it and render on demand, and causes a flush if you use a caching layer that doesn't really help you and all that. But you can easily just use the Ganglia monitor D and feed into Graphite.
Yeah, absolutely. And I'm not saying that there aren't solutions. What you're talking about are working around deficiencies that are in the base thing itself. I mean, the people who wrote Ganglia didn't write it saying, I'm going to make part of a solution which then people will augment with Carbon, or Graphite, I mean. Instead, people have come along and said, okay, that's nice, but I really need something better than what you have for this, so I'm going to try and graft on something else. But while we can mix and match components in a web app, Nobody building monitoring systems, well I don't say nobody, but the majority of monitoring systems are try to be built as complete solutions, okay? And what that means is that everybody comes along and says, oh, you know, I really don't like the weak configuration management of this service, not pointing at Ganglia itself, or I don't like the visualization, and then they try and fit something better on top of it. Okay, I know that Ganglia is writing out RD files, and so I can figure out how to get that data from the RD files into a different visualization, and so on. And we see an evolution. Cacti is very much MRTG. The focus in Cacti is around the configuration elements of MRTG. MRTG is a bitch to configure. Hopefully no one here has ever had to do it or hasn't had to do it in the last 10 years because it's got this one fat config file. Cacti tries to make a much easier way of configuring a very complex nested hierarchy of things, but it's still based on MRTG more or less. Sensu and Logstash, have I already gotten that for you? I want to get all the way to Shinken. What?
There's one with green.
Yeah, now this isn't an endorsement by any means, okay? I'll explain the colors in my talk tomorrow, but all this means is that in Shinken, this attempts to be a complete solution that is actually wrapping up a common hack that many people do. It takes Nagios, adds Graphite, adds a custom configuration management layer to solve the fact that Nagios doesn't shard very well. Basically, Nagios is one fat, who's configured Nagios before? So you all know what I'm talking about. The config file is, I mean, people have made tools to try and generate config files and so on. Shinken, basically, they have created support for generating your configs and then taking that config and splitting it into chunks, sharding that config, and farming it out to different nodes that are then doing the polling and then bringing the data back in and storing it, okay? And they use RD tool and they expect that you'll use Graphite for the visualization layer. So they're essentially, they've solved the weak configuration management. It's not a perfect solution, but it's much better than using straight Nagios. They've solved the visualization by taking the most common trick, which is you take Graphite and you put it in front of the RD files that are being generated. And they solved the collection by saying, okay, the real world is you need to be able to shard out the collection of this. An environment where you have one monitoring host which has direct network access to everything being monitored is old school. No one has that type of environment anymore. Your hosts are sitting in an AWS cloud and you need to be able to collect the data from inside the AWS cloud and bring a single stream back down. You have remote sites, remote data centers, and so on. So when implementing, to sum up, because I want to just be very quick, when implementing a monitoring system, you have to solve all 7 of these problems, and you have to solve it in a way that addresses somewhat conflicting needs. Anyone here use D3? Yeah, it's a lot of fun. It's a little hard. It's a lot harder to use than Graphite because it's meant to. It seems like it's more meant to explore a static data set. But anyway, I'd love it if I could, when it comes time to do spot diagnosis, I could say, you know what? I want to instrument this server for the next hour and then generate a whole bunch of interactive D3 graphs. Let me just explore what happened during that hour. If anyone wants to write that, I'll give you $1. There's no money in open source, what can I say? So anyway, when you want to build monitoring, you have to solve all 7 of these boxes, and you have to address at least these 4 needs. And the dimensions that these needs vary on are the resolution of the data you're gathering. And by resolution, I'm talking about, are you collecting every 6 seconds, every 6 minutes, every hour? The latency that you're willing to accept for data to complete the processing pipeline. If you're using something like Logstash or Loggly or so on, then you have a much longer latency for data to be written, especially if you're relying on something like hourly rotation of log files and copying up to a log processor. Then the latency becomes a problem. Like, you don't want to find out an hour later that, oh, by the way, something caught fire and exploded because it took that long to copy the log file over and process it and import it into your monitoring system. QA and SLA, this is where I lump in all of that forensic analysis metrics, okay? Now that's very much like operations, and you need quite a bit of detail, but the latency isn't there. It's okay, for instance, if you got a dtrace after the fact, if you were able to trigger it when an event occurred. Like if you were waiting for a particular condition to occur and you triggered a dtrace, you trapped it and then sent it off to then go pick through at your leisure, or any of the other tracing mechanisms. You don't need, it's not a real-time interactive thing necessarily, all right? As well as SLA analysis, there you do a lot less data. You're just looking, being your key, computing your key SLIs and so on, but the latency is much lower, and depending upon whether you're doing forensic analysis, you want very high resolution, or if you're just doing SLI computation, you need very low resolution. And then what was it? Oh, product management. And this is the absolute far end where you have the least interesting kind of metrics, the ones you're computing on a weekly basis or a monthly or a quarterly basis to say, here's how many 7-day actives we have, here's how many new users we have signed up, here's how many times per day they access our product, the number of visits per session and so on. I'm sorry, the number of RPC calls per session and whatnot. Those are the most processed kind of metrics, and they also have the highest latency. So using those 3 dimensions of resolution, latency, and what was it?
Processing, visualization?
What does the P stand for? Oh, D, diversity, sorry. Diversity, how many different metrics you have. So there's how many different metrics you have, there's how often, how frequently you sample them, and there's how quickly you get that entire data set to the end of the pipeline. That impacts your choice on how you implement these. If you're only serving the product management model, then you can get away with analog, and the analog is another great family tree of systems to go and look at. You start with the analog, which came out in '96. Anyone remember where an analog was written? Who knows what I'm talking about when I say analog? A couple people, all right. Analog was one of the first things that basically ingested Apache log files and generated a static collection of like 5 or 6 HTML pages with histograms on it that showed, okay, based on time of day, here's how many hits you got, and it was just hits per hour, that kind of stuff. It was a very early time. I should really find a screenshot of that because it's not about Linux.
It's 1992 or so.
Yeah, I mean, I used to run it over my my CERN HTTPD logs. It's that old. It predates Apache. So anyway, but these 3 requirements change the engineering trade-offs you make when designing each of these components. And so when you implement it, you have to make sure you hit all these boxes. And if you look at the workarounds that you've made in your monitoring system, and if anyone wants to volunteer to describe their monitoring system, I'd love to see how it fits in this model. You'll find that the things that you weren't able to do off the shelf probably were to address shortcomings in one or more of these boxes. Either the implementation was insufficient or it just didn't have any support for it.
Yeah.
So.
ES monitoring system.
So I would love to start with the open. So we came to the exact same conclusion as all of this, probably around the same time. This is not a recent conclusion of yours.
No, this is the first opportunity where we can talk about this publicly.
Right.
But this is the model we use inside of Google when we're building and evaluating our monitoring system. This is basically when we look at a design, we say, okay, how does it address these individual elements?
Yeah, about 4 years ago, we realized how miserable we were with all the monitoring solutions that were out there, and realized that the basic problem and the reason we were miserable is because everything was evolved from Nagios and MRTG, right?
Yeah.
So we built an open source monitoring system that has no group, no family tree. It's from scratch. It actually does something. It looks a lot like this, with a lot of focus on making sure that the configuration aspects of it are highly distributed and decoupled. So the idea is that you have the sensing, measurement, and collection kind of wrapped into a component that can be deployed anywhere, in any rack, any regulatory compliance environment, and can be configured there completely. So the people that have access to that environment can actually configure it completely disconnected from home base.
Okay.
So all the configuration is completely distributed, and then merges on the upstream.
Now that is a trade-off though, because sometimes you want to enable leaves to do their own thing,
Yep.
and other times you want to make sure from a central point that you've got all your bases covered.
And you can flip that on and off and do it both ways.
Cool.
So everything, so the remote node looks like a Cisco iOS console. You can log in and see all the configuration management, mess with it, but it also has a fully SSL REST API. So you can configure from anywhere with full PKI, so you can use keys and make sure only the right people can instrument it.
Yeah.
All of that stuff funnels up, storing forward over SSL into a central processing core that basically its job is to dump junk into storage.
Yep.
And to junk into a message queue for the pickup of
processing.
all those other components, the analysis, the escalation and alerting. The alerting system is all done as of a couple weeks ago was we ripped out Esper, which we were using, and we dumped in Riemann, which is AFIR's, so Kyle Kingsbury. He wrote something in Clojure that does stream analysis and stream processing, so you can manage millions of metrics per second and describe arbitrary complex alerting and escalation rules around them and fire on them, so it can natively absorb all of that.
Yeah. Now, there's alerting. I have alerting and escalation in one thing. Very often, the determination that there's an anomaly that you have an alert is one thing.
Yeah, we separate those.
Getting it into someone's pager reliably is another. And I kind of, I have analysis, computation, alerting, escalation. Those four things, I'm not 100% positive if there aren't 3 boxes in these 2 as opposed to 2. But I'm hoping to create discussion around this model, because if we can come up with a generalized model, I mean, it'd be great if I could pick off the shelf, I want to use this person's alerting service and that person's storage layer and this person's visualization. I shouldn't have to hand build everything. Now, I like fully integrated solutions, but that's the great thing about open source. Even the fully integrated ones, you can fix the things that are pain points for you. Some people value centralized controller configuration more than they value, say, flexible collection, whereas others, yeah, go ahead. Please interrupt me.
Out of your 5 little boxes there,
Yeah.
Can you characterize the bottom 3 boxes as all just variations on rendering?
You could. The difference between when it comes to analysis is that analysis covers a couple different areas. What the engineer does when they're looking at a visualization, yes, that's analysis. But I'm not talking about an engineer doing analysis. I'm talking about automated looking for thresholds and trends and applying rules to determine if you need to create an alarm, or computing derived elements, such as taking an incoming sequence of user activity information and then computing how many people are live on my service right this moment. So that's what I'm kind of basically creating derived metrics is what I'm referring to when I say analysis. And then one of those derived metrics it can be seen as, is there an anomaly going on right now? And sometimes you need to be able to mix data from multiple sources. For instance, very high I/O wait times. It's very easy to put in thresholds on, if my I/O wait gets too big, I want to be paged. But it's better if you can make sure that high I/O wait time alerts are conditioned upon their relationship to the active number of the active amount of incoming connections on the site, right? Because what's an unusual I/O wait load for 100 users simultaneously accessing your service is different than an acceptable I/O wait for 100,000 users accessing your service. And so combining and synthesizing those metrics is very important. Many systems still only do that kind of first order analysis where they'll look at a single time series or all of the values in the same type of time series and then alert on that, as opposed to saying, I want to combine I/O time series with user activity time series and try and draw a correlation. Because then you get much more powerful alerting. You can, it'd be great if at 9 in the morning, I get the alert that the relationship between I/O load and user activity is out of whack, not wait until the 1 p.m. peak when my hard drives completely fall over. Yeah, I'm still servicing the load completely at 9 a.m. It's well within my response times, but the ratio of user activity to disk activity is off. And if this trend continues, I'm no longer going to be able to service it come my usual noon load or afternoon load, Because then it's like, that launch that pushed out, yesterday afternoon or this morning, I need to roll that back now, because if I don't, I will have an outage in 6 hours. And if you don't combine metrics from seemingly completely different fields, there's no way for you to catch that before it happens.
Out of curiosity, this is the model you apply inside of Google, but do you actually use any open source products to do any of this stuff?
Unfortunately, we discovered what a lot of people do is that open source kind of falls down. I've got it.
I'm thinking that was actually my point. Was that, like the other integrations, it would be great to plug and play all the components, but not all of them scale.
Right now, what I see out there is one component that if I was building an open source monitoring system, this is the one thing that was written as a component, designed to be a pluggable component in a general monitoring stack.
Like somebody spent 3 years using the Google one.
Yeah, it was written by a guy at Yahoo who wrote it after he left Google and realized that crap, they didn't have something that is really, really useful to underpin their monitoring collection to gather the amount of data that they want. And so we wrote an open source version of what we use inside and released it because Yahoo really is good at open sourcing stuff. We love it when...
I think this is an open challenge, mainly because you can install OpenTSDB on a single box, and it's actually manageable. But someone was laughing earlier about managing crap through DB2, so now they had to have a DB2 event. If you actually try to scale OpenTSDB, you need an...
It goes into HBase, though.
I know. You need a Hadoop administrator now.
Oh, wow.
But yes, I'm
hang on. This is important. Monitoring today, and this is, I'm trying to figure out how I'm going to put this into a talk and where I'm going to give it. Monitoring today is a big data problem.
Yes.
It is, and we're going to have to apply big data solutions to it. No longer can you have single-threaded servers or single servers that are trying to look through a time series and produce a graph. You have to apply what we know works for scanning. Every time I produce a graph, it's ordinary that my monitoring system to produce that one graph, even a single line graph, will have to bulk read 12 terabytes of data. You cannot do that linearly in any architecture in a responsive time. How do you do that? Time-space transformation. You need to apply big data techniques to it.
I would say that my point of view on that is far more skeptical. I've worked in the financial services industry for a long time as well. So like our big data problems in monitoring are actually even now approaching the same size that financial transaction monitoring and high frequency trading did, and they don't process 12 terabytes of data. And the reason for that is because the tools for it are as awful as Hadoop, right? Hadoop is like the sledgehammer for every screw in the drywall, right? So the problem is that the OpenTSDB, maybe the internal Google one is much more purpose-built for time series data, but HBase and OpenTSDB is stacked on a system that by the time you get to the bottom, you're like, why would anyone ever use this for time series data?
The issue is when you're implementing the analysis, alerting, visualization, configuration. It's fine. People use it every day for its purpose. What it doesn't work for is large data. And the problem is we've now the entire way in which Graphite operates is incompatible with big data. In fact, all of the common visualization elements, they don't work with big data when they go directly to the data because they're all written around that model. Yeah.
Well, I think that both Graphite and Ganglia, like you said, I work on both of them. I'm a maintainer on Graphite. Both of them are intended to be a vertical stack of bits that can work with other parts. Chris Davis, who originally wrote Graphite, released it to open source ahead of going to Google so that he can guarantee it was released.
Yeah.
And it was always meant to have a pluggable storage backend.
Yeah.
And OpenTSDB was actually the first target to be another drive render.
It has a pluggable storage.
Was just written as like he needed something that would store data until something better stored data. And it turned out it worked well enough.
Yeah.
And so a lot of people adopted it. But it's hard
it has a pluggable storage.
I also think that it's also not, I don't think it's fair to say that it's not amenable to the big data.
The issue is the way Graphite functions in most people's deployment is it uses the pluggable storage backend.
The per file metric stuff is actually very purpose-built.
No. A pluggable storage backend is not the same as a pluggable query backend.
Oh, sure.
Okay.
The query engine doesn't exist.
Exactly, and that's the problem. Your visualization layer needs to be issuing queries which go to a system that can then take the 12 terabytes of data and produce the 100K of data, the 1 megabyte, the 3 megabytes of data needed to produce that visualization. And when people then try and take Graphite and glue its storage layer onto OpenTSDB or any of the others, that's when it falls over because you have something that's really trying to do a storage layer because they've implemented the query language right there. Now, I don't know the internals of Graphite. If a good query layer can be added onto it, that'd be awesome because then you can, instead of talking to a library, you talk via an RPC, a JSON query, whatever you want, a RESTful API, which then does the fan out to a collection of workers, synthesizes the result, and sends it back. A reasonable operational monitoring system is going to be getting today, at moderate size, half a terabyte a day of data. And so if I want to look at a 30-day graph, I have to read 15 terabytes of data because all of the information I need is in that data set. And to pull out one line graph, whether I want 1 line or 1,000 lines on my graph, I need to go through all 15 terabytes of that data.
We don't do that for all the graphs that we draw. But if you actually distill scanning 12 terabytes of data, or whatever is 20 terabytes of data.
12, it doesn't matter.
Whatever, 15 terabytes.
More
of
than
data.
can be done in one pass.
Yeah, I'm worried about like how many pennies does that cost? How many pennies does it cost to scan 12 terabytes of data?
I don't have the number off the top of my head, but it's not expensive.
It's got to be 1, maybe?
No, I don't think it even comes close to 1.
1 penny to scan 12 terabytes?
Yeah.
Okay. Because when we did the economic model, so we have like a single client. What we see is a single client with like a rack or 2 of machines.
Mm-hmm.
They send us about 60,000 metrics per second all day long.
Mm-hmm.
So that's every latency off every database query, every latency off every memcache query, all that kind of stuff. And the infrastructure that, I mean, they need to be able to pay like, $500 a month to be able to get all the graphs that they want and store all that data forever.
I understand.
So it seems like the economic model of having to actually scan all that data to draw the line graph. Because once you've drawn that
all
line
I'm
graph.
saying is, well, you're making a very different argument. You're saying that it's not economical for someone to pay someone to provide this service. I'm saying that open source solutions to data monitoring aren't capable of keeping up with this type of load. But I know from personal experience it is possible to build systems that can keep up with that kind of load. And what we've seen over the past 15 years is that everything's getting bigger all the time. So while we can do it today, what we're doing today, everyone's going to be doing in 5-10 years. Because what everybody's doing today is what we were doing 5-10 years ago. And so we're going to need a solution that can do this in the open source world. Because no longer are people going to be content with 15 metrics, 20 metrics, even 100 metrics that describe their system. They're going to want 10,000 metrics. You know, I work up this simple example, which is a toy example, as to how I end up getting to that total. And I'm using simply 25 metrics per server, all right? For I think it's 100 million user service. 100 million users a week, all right? Which is I'm sure any startup, any company would want to have at least 100 million active users to be a thriving business, right? If you're only collecting 25 metrics per server, you're going to end up at that ½ terabyte a day of data, right? Now you can serve 100 million users using a completely open source stack. And that's great because that's what allows companies to do that. But what we're doing is the sysadmins are feeling the pain of not being able to manage that stack because the tools aren't there. Because we're not building them in a way that's anticipating this. We're continuing to evolve tools that are instances of they're the many grandchild of one of a couple of systems. And furthermore, when people are implementing them, they're not implementing them thinking, I have a big data problem. They're saying, all right, I'm going to start from first principle, I'm going to build a brand new monitoring system, right? And they go out and they build it, but they're thinking small. If you say, I need to build a monitoring system that's going to have 15 terabytes of new data a month, and I want to be able to have it generate interactive graphs for the last 30 days, that's a different question, and people aren't doing that. They're instead saying, okay, what are the cool graphs? I need to be able to generate histograms of this, and they're doing that without thinking of how does that data get into there? What are all the parts that I need in order to collect that much data from a farm of 1,000 servers or even just 100 AWS instances, right? Because you need a way of bringing all that data together. We need solutions that can operate at scale. And we need them in ways that work together because no one person's gonna be able to write an open source solution to the entire stack. It's too complex. I don't understand half of the monitoring system at Google because it is extremely complex, right? Even just Ganglia was a great solution to the distribution. It tries to solve one of the problems. Now, if you can take the lessons of Ganglia, figure out how do we make it solve the one part that it does really well even better, and have it work with something like Sensa, which is an example of a system that does distribution and routing, right? It routes to active agents that will then do the analysis portion. Then we write, Nagios, what it hit really well is the pluggable sensing and measurement, okay? Now the execution model is crap, all right? Everybody switches to the push model to push metrics in because running a process every time you want to gather some data, it's a disaster. But they had it right there. You need a way that it was very easy for someone to write this much code and sense data from something that nobody ever even thought they would want to bring data into, right? And so that one idea has survived through every descendant of Nagios, and even the people who re-implemented a Nagios-like system and say, you know what, I'm going to make it compatible with Nagios plugins. Because there's so many of them, it's great. They're pluggable, right? But we don't have pluggable solutions or even easy interoperability. No one here will say that MySQL is a pluggable replacement for PostgreSQL, will they? No?
Depends how it's used.
What?
Depends how it's used.
Even with JDBC, even with an OR mapper, no one here, it's not pluggable the same way a Nagios plugin is pluggable, okay? It's not even pluggable in the way my video card's pluggable in my
If you're storing key value pairs in both of them, then you're pretty much set. So if you
yeah,
have a
but
system-
who uses an RDBMS and doesn't use the RDBMS? I mean, if you're using it like
People
DB, like,
people who want to use key value pairs. I mean, that's where that ends, though. I assume certainly if you're going to use the
but
relationship
they're not
model-
they're not pluggable. So they're not pluggable equivalents. But
Correct.
you can build a web app and say I'm going to make a decision between these two backends, which fill the same purposeful need. Now, if you want to go NoSQL, there are also many NoSQL solutions. But there's a model that we have for working with them.
Did you say that any of the components in your stack is actually free?
Everything I described is free.
Awesome.
I mean, I feel like a lot of this is, there's a lot of other open source monitoring solutions out there as well.
I had to stop at 70 slides.
Yeah.
I mean,
So like the highly distributed collection, the volume, the push versus pull, running Nagios plugins, all that stuff, that's all built into Reconnoiter. The whole system's built from the ground up, and it's all BSD licensed, all open source.
that's great.
And it's designed to accommodate the fact that every single one of these components shits the bed when you hit volume. So, and it natively produces stuff that can be ingested into Hive, for example.
That's great.
So-
Yeah, and so
But all
you're
of
you're
this
you're
is-
ahead of everybody else, and I'm saying let's do this in a way that
Well,
It's
actually,
anyone who's using it is ahead of anyone who's not, right? I mean, it's been around for 2.5 years, and there's competitive services to ours that are built on top of it.
great.
do you feed Zirconis with that stack?
Yeah, Rackspace Cloud Monitoring stuff uses it under the hood as well.
Okay.
So,
Great.
I mean, that's awesome. Like when we actually discussed this yesterday, it did not come up. It was one of those, but I think the context was like, when we do this session in the workshop, what are we going to say that people are going to go and look at? And this is
Yeah.
like a good,
I'll tell you that you can dump all the data into Hive or Hadoop or whatever you want. It's tab separated data, right? So you can dump it there. What do you do with it? How you plug that into Graphite?
right?
They're all pluggable, but no one's actually plugged them together,
Yeah.
right? You can dump all that stuff through Riemann, but you're gonna have to write the rules,
Right.
right? So the thing that our commercial product does is builds the entire platform on top of that.
Right.
Which, if you're gonna be honestly, if you're gonna be building a really big system, you would do the same thing that we did. You would build a platform on top of that by taking the components and replacing the ones that are proprietary magic. So there's a lot of companies out there. So I agree with you, the alerting, the analysis, alerting stuff, we split that into 3 boxes as well. Marketing has it as 2, but we have it as 3. So alerting, so anomaly detection, and the case management and escalation are separate components.
Yeah. Yeah, there's whole workflow related
Yeah,
elements that
absolutely.
are external to this. Just as while you have configuration management, the workflow around your configuration management is going to change. We have our own systems. Basically, once something's been fired out of the alerting system, that other thing, which is more of a job tracker, task tracker type thing,
Right.
takes over because that has its
It
own
does.
style. And also, there's no reason to complicate something that's already complicated enough with it.
Right.
So-
And then the idea of hooking them all together, and I hear the exact same thing from the open source monitoring sucks realm, which is what we really need is componentized systems.
Yeah.
The irony is that they're all highly componentized.
Well, I'm saying, my assertion is this is a good first pass at what the components should be.
yeah, and I think that so I would agree that the legacy open source applications, so Graphite, for example, it touches on storage, touches on that, Carbon does, but Graphite really sits in one block. It is visualization.
Yeah.
Right, and it does a good job, arguably does a good job. I'm not a huge fan of it, but there are a lot of huge fans of
So-
Graphite, right?
something
They really
that-
like it, it does that. It fits the
Something
need.
that converts a table or many tables of data into a visualization, into a pretty picture that conveys information is what I call the visualization layer. The problem is when your visualization layer does that by looking at the entire data set to figure out that, you need something else to produce that block. This link right here, right now it's being treated as a read to disk, when in reality your storage layer needs to be intelligent. It needs to be, you need to be able to express things in terms of queries to it, not in terms of open up these metrics, give me the last 30 days, I'll then subsample them down to the 5-minute intervals that I'm trying to render right now, because it's the wrong place to do that. You can't do that in a linear fashion because you're gonna have too much data. You may not have it today when you have 10 servers, you may not have it today when you have 100 servers. But we routinely have services right now, even small ones, that have 1,000 servers or 10,000 servers.
So there is also a magnitude difference, and I think that it's everywhere, and there's probably people that collect more data than us. So there's a lot of organizations that collect 1,000 metrics, and they do it once a minute.
Yeah.
Right? And then you had a number up there of 13,000 metrics a second.
Yeah.
In
Something like that, yeah.
one of your slides at the end. So we have really small architectures that produce 4 or 5 billion telemetry points a day, like really small architectures. They pay a hosting bill that's $1,500 a month, and they can produce easily 10 terabytes of metrics a day.
Mm-hmm.
Right? And they love to ask questions on that, but it's not economically feasible for them to crunch that data after the fact. So there is an opportunity to turn that problem the other way around.
Okay.
By materializing the queries instead. So it's a different approach. Obviously, it's not as flexible, but it's way cheaper in that you can up your volume dramatically, but then define the views that you want on that and have those materialize as the data arrives.
I mean, remember, we're talking about a service that has 100 million users. Hopefully, they can afford $1,500 a month for their monitoring because their hosting bills can be much bigger than that.
So we have clients that serve 100 million users, and their hosting bill is like $2,000 or $3,000.
Well, good for them. I'm very happy for them. When we use virtualization to throw at problems, what it's causing, as we specialize our servers, it's creating an explosion of the number of servers. It doesn't matter that you have 25 servers that are single purpose, because you're still getting the full set of metrics from every single one of them. So whereas formerly when we were dealing with bare metal, we might say, you know what, I'm going to get one server, I'm going to pack as much into it because I need to be efficient with my hardware purchases. Virtualization allows us to take that same 16 core, 64 gig of RAM machine and put 25 virtual machines in there, each doing one little piece of the pipeline. But now you have 25 times the monitoring data. The monitoring system doesn't care whether they're real machines or virtual machines. And for someone who's buying their own bare metal, it's very easy for them to, and the trend is now, they're going to use virtualization, which means every one of their physical machines is now multiple virtual machines. And so your metric volume is increasing at the rate that you're adding virtual machines, not at the rate you're adding bare metal. And so that creates its own problem. So even if you aren't collecting this much data today, you will be soon. Everybody today is managing more servers. We manage more servers today than easily 10 times more than we did 5 years ago because of virtualization. Instead of having 1 or 2 servers and a hot spare, we now have a stack of 15 AWS instances. That's going from 3 to 15. It's a 5 times increase in the number of servers do pretty much the same job, right? And that trend is continuing to accelerate. So, monitoring is big data. We need to apply big data solutions to it so that we can keep up with it. Because, this is today. In 5 years, we're going to be way beyond this. We're going to be using 1,000 servers to do what we do today with 10, or 100. Easily, in 10 years, 100,000 servers. Just mentally go back 10 years. The year's 2004. 2013? Yeah. 2004. What? 13? 13. All right, the year's 2000. I'm here for my looks, not for my brains.
Back to the future.
Yeah. In 2003, how many servers were you responsible for? How big was your fleet? Right? Odds are they'd be toys today by modern standards. Right? And 10 years from now, the change is going to be that much more intense. Right? And our monitoring systems, if they haven't evolved beyond the techniques we were using 10 years ago, then we're going to be even more pain than we are now. So, I'm depressing myself now. Anyway,
someone say something. Another not a difference to that, but like in addition to that, I think the dynamics of metric collection, because this is systems metrics. So as soon as
No, when I say server, I'm talking about, Google uses the word server to mean a process on a machine.
Okay, all right. So
it explodes the problem even further because...
Yeah, absolutely. So if we did a survey across our customers because we changed the pricing model, we found that on average per physical machine, per node, virtual machine, physical machine, whatever it was, they had an average of 45 metrics that were systems level metrics. That was like TCP stack, memory, disk, I/O, this, that, and the other. Yeah. As soon as you gave the power to instrument the app to the application developer, 1,000 more metrics showed up.
Yeah, as I said, this is a toy example.
Yeah.
I mean,
so what I'm predicting.
That 1,000 more metrics is rarely collected at that same granularity. You usually have some pre-aggregation step. I mean, look at the popularity of things like StatsD. I mean, and the reference implementation of StatsD will fall over at 40,000 queries per second. Like you couldn't even fit those metrics through it. It just doesn't do that.
Right. So use things other than StatsD for that.
Well, I'm just saying that's a popular example that proves the popularity of the
yes.
scales.
Yeah, absolutely. They want it, and I would say that application developers sometimes today they don't want it because they can't use it because it falls over. But they want it, then they're neutered, right? So like they're really excited, and then someone just smacks them down. But the idea of having all of your telemetry data from your app, like, can you imagine an Oracle developer? The idea of being able to emit arbitrary telemetry from the database for permanent storage. That would be crazy. They would have 10,000 metrics a second coming out easily. The database would be idle, right? So that stuff, there is no economic way to store all of that data and provide more value than it costs to store and query it. Yeah. It's so much data. So there is another...
Attenuating the hose is its own problem.
And I don't think we want to attenuate the hose. Well, I think we want the data to come in.
I don't want to discourage developers from adding those metrics. As
right.
a sysadmin, I want to find out that, if I add dash metrics on, I have those 1,000 metrics available to figure out what the heck is going on inside their damn black box.
But the networking is free. It's only the storage that's not. So the question is
it's
what?
Not that free. I mean, if every suite right now is 320 megabytes, because where are you going to start attenuating that incoming flow? That's a little over a gigabit per second.
That's per minute.
Oh, sorry, gigabit per minute. Yeah.
It's very compressible, right?
What?
They're very
It is very
compressible.
compressible, but is the application compressing it before it ships it out, or after you collect it, you compress it?
Well, I mean, you kind of have to
Ours are
look at a time series to compress it and say, okay.
Well, I know, but at collection time, it's not a time series. It's just a dump of a bunch of
But
metrics.
we're talking about storage as well.
So
Ours are compressed as they go on the wire.
Okay.
So, but I mean, like I said, we have clients that send us like 60,000 metrics a second, and it takes maybe 3 megabits, 4 megabits.
Okay.
So the idea of them using that, and now they're all running 10 gigabit Ethernet, so that's really not that much. But they cannot get enough value out of that today to justify storing it. So then the real question is, in addition to all of this, that analysis layer, you can do all of that analysis in real time. Where are the clever innovations that are happening there? So I think there's a huge market of clever innovations that can happen for real-time stream processing on that data stream.
I take your point, and I think you and I differ on the inherent value of collecting that entire stream, because you don't know what questions you want to ask of that stream.
I agree.
And figuring out a way to cost-effectively deal with it, it's a valuable strategic advantage of someone who can capture and use that to understand the behavior of their systems.
I don't agree with that. I don't disagree that there are definitely questions I can't answer today. I don't know how to phrase today. And without that data, I can't answer them retroactively. I am losing valuable information. The question is that value is an opportunity value.
Oh, yeah.
And there is a cost that's not an opportunity cost. It's a real cost of storing that data, building out a data center to hold it, being able to get it back in a time that's reasonable to even answer the question temporally relevant, right? And we haven't reconciled that. We have clients today that collect information where they get, I don't know, maybe a couple $1,000s worth of value a month out of the stuff that they can answer, because that's their revenue stream, right? So if you make $1 billion and you have 40,000 servers, 400,000 servers, the economics of it, I think, dramatically change.
Perhaps.
I hope. Maybe.
I mean, I don't know. I don't make those kind of analyses. I mean, I'm given metrics that I'm to use when I'm trying to compute the relative value of a terabyte of data on disk for a year.
Yep.
And by our math and by our techniques, we're yet to see a point where that's coming close to inverting.
Okay.
And every year we're collecting more metrics than we did the year before. Not just because we're expanding the size of the fleet, but each process is generating more metrics than it did a year before.
Yeah, we see that. I guess our customers haven't found a way to generate that much value out of them.
Yeah.
That said, there's still also people who will go, great, I'm just going to kick off this job which will work out all the metrics and time series that haven't been used in 12 months and purged.
Yeah.
Everything that has been used for 6 months and purged until reflected.
Yeah. I mean, if you have instrumented your visualization and alerting system, it is straightforward to say, well, what data hasn't been touched in the last 12 months? And that there says, you know what, that's our horizon. If nobody looks at this data for a year, you purge it. You know? But the way disk space is accelerating, the fact is that,
Also, where to get rid of it.
well, yeah, I mean, a year's worth of data from 3 years ago is a quarter's worth of data today. And you're already having to add capacity to keep ahead of the incoming data curve. Is there any point in going back and deleting data, which you're deleting less data than the capacity you've added in the past 6 months? You know, it ends up being pointless to go back and delete data. Because yes, today that's a big amount of data. But in 2 years, half a terabyte is going to be as cheap as, you know, as 50 gigabytes was 2 years ago. You know?
Well, you can use some sort of LCA model to demote data instead of evicting it from your storage.
And here's the thing, we are downsampling.
And that allows you to put a cost that is at least somewhat relevant to what your value that you give to your data.
We are downsampling. And just because we're collecting at minutely intervals right now of 50,000 metrics, 100,000 metrics, doesn't mean that I'm going to ever care, you know, what all 50,000 of those counters were at 3:15 in the afternoon, May 7th of 2012.
Doesn't matter if you cared, you couldn't render it.
Well,
We can. We do.
What do you mean?
Our clients really
Well,
do care.
I'm saying there's only so many pixels on a screen. Like,
no.
you
I'm not looking at the
data
internet. I'm
when
saying
it's
if I zoom in to 3:15 p.m.
Yep.
that day, because I'm looking, because I just had an experience, because like, let's say 3:15 today, something weird happened. Was there something else in the past that did the same weird thing? Odds are I'm not going to go that much resolution that far back. So downsampling to, you know, minutely and then hourly and then daily resolution as you go back in time is perfectly normal, and and the data shrinks tremendously.
Our market research shows that that's a high frustration factor amongst customers.
Yeah.
Yeah. So what they do is they'll be planning for Black Friday this year, and they're looking at their systems and they're trying to. What they do is they do like game day exercises, and they'll rehash last year. So they pull up the day of last year and they want 1 minute data. They want to be able to look at everything. And then they also be able to look at like individual spikes. And of course, you know, a minute's never enough, but you have to stop somewhere. You'll have a specific spike and they want to know, were we spiky like that or were we just high in the past? And it's a huge frustration factor that gets averaged out.
Yeah, and I mean, ideally when you're making decisions, you're doing it data-driven, not just guessing at what people want and what they don't.
Yep.
You have instrumented your front end such that you can say, what did people look at in the past year about the previous years? And you know, in that case, oh, it turns out that there are certain times of the year, Thanksgiving, Christmas, and so on, that people really do want to look at that data. And if you have the data about what people were doing, you can answer those questions. Otherwise, you're just making educated guesses.
One of the challenges with our RD tool is that you don't have that data because everyone knows they can't go back. So no one ever goes back to look at 2-year-old data because it looks like a 12-hour average, so why bother?
Yeah. But once you give people access to this data, they begin, again, discovering questions
Absolutely.
they didn't really want to ask.
The spelunking exercises that people go on are
It
quite
does depend
fascinating.
on what kind of organization you have. Like, we
Yeah.
do it for a bunch of people who are lots of spare time on their hands. They go through random stuff and go, oh, check it out, we just found an interesting drive access pattern that seems to indicate flaky hard drives that we've seen in 2006, 2009, and now with this new drive.
Yeah. Where else did we see those? And you need all the data to be able to match that pattern
you
everywhere.
need people with spare time to go through it. You're saying that a lot of your customers just don't have that.
Yeah, a lot of the customers, they want, I mean, it's always a limit, right? So we roll up a lot of data. I mean, just like the other products, just like MRTG, right? You roll up data into a certain thing. One of the differences in the Reconnoiter stuff is that it doesn't manually roll them. It doesn't degrade those granularity intervals. So you can look at 1 minute from 10 years ago if you had a storage space for it.
Mm-hmm.
But what we don't do is we don't store all of the, we don't tend to store all of the individual observed metrics, which would allow us to recrunch things in fascinating ways. And mainly we don't store that because customers won't pay for it.
Yeah.
They don't have the value. And I'm making a huge leap there that if they won't pay us for the storage because we don't mark storage up, that they won't buy it themselves. Like
Possibly, yeah.
They don't have that model.
Yeah, I mean, yeah. To keep myself some perspective, I have on my wall at home. I was involved in a startup, as many people were, back in 1996 and 97, and I have 2 CDs, writable CDs, that have a year and a half's worth of compressed web access logs from their servers. A year and a half's worth of HTTP Apache logs on 2 CDs. And I think the second CD is mostly empty, And when I look at that amount of data and say, am I going to have this, in 10, 12 years, am I going to have that same perspective of what I have of my a year, 12,
It's not the cost for writing it and storing it.
80.
It's the cost for reading it again.
well,
That just to be clear, it's yeah. I mean, I can store it. In fact, in our systems, it takes more IOPS to delete the data. I'd rather buy more drives.
but if nobody's looking at it, then you're not reading it. If you're paying to read.
Nobody's looking at it because they can't pay to read it. If someone goes and looks at it, the bill goes up, and they can't afford that.
Okay.
So that's. I think that's.
You're presenting very real problems that your customers have, and I don't disagree with that.